So thank you very much for the introduction. And I realize I'm the obstacle for your beer, so I'll try to keep it short and sweet. So what I want to talk to you today about, we've been hearing lots and lots of things about LLMs and the vision language models. And I want to sort of take a sort of step above this and talk a bit more about what it means to sort of build machine learning applications in the open source ecosystem. And if you're brand new to machine learning, your first question might be like, okay, what the fuck is Hugging Face? Is it an emoji? This is often what my parents ask me. They still can't believe I work for a company that looks like this. So hopefully by the end of this, it will actually be clearer if you've never heard of what we do. So the place to start actually goes all the way back to 2011. So Mark Anderson wrote a very provocative essay at the time where he was pointing out that a lot of the skepticism that people had around software companies like Facebook, Meta, which was actually Facebook at the time, Twitter, was actually not justified because these companies were actually producing defensible businesses and also had the ability to grow at a global scale. And so he wrote this thing saying that software is eating the world. It's going to be the primary means of how we build businesses and how we communicate with each other. And the tools of the trade were obviously software, but then APIs, software as a service, and then cloud infrastructure. And a few years later, deep learning sort of really came into the scene. It had been kind of invented many decades before, but it was only thanks to developments in hardware that it was actually practical and useful. And Andrej Karpathy wrote a really nice essay talking about software 2.0, where he was making the argument that we were used to writing all our software with hard-coded logic, but there was a new paradigm emerging where we could use neural networks to essentially learn from data how to solve some very complex problems. And the kind of tools of the trade at the time were convolutional neural networks for modeling images, but also for modeling text. We had things like recurrent neural networks and LSTMs. So this was sort of a new paradigm shift where instead of having to write your program explicitly, you wrote the algorithm that learned the program. And if we fast forward to today, we can see that transformers are actually now kind of eating the whole of deep learning. And so what started initially as a very focused architecture for machine translation gradually grew into text generation, into computer vision, into audio with Whisper, and is more or less encapsulating almost any domain where you have some sequential data that you would like to model. And in the State of the AI report a few years ago, they sort of made this observation that it's kind of becoming the general purpose architecture for solving most of the sort of very complex problems that we would want to model. And one of the things that's been happening at increasing pace is getting beyond just this text modality. We can see that in the last few years, there's been a growth into these other domains like multimodal models, audio, and the next frontier is indeed video, as we saw from the nice talk by Pablo and Dominic. This is likely going to be where we're going to see the next state-of-the-art models emerge. And this isn't just research. You've now probably heard many talks of how transformers are being deployed into real-world products. If you're using VS Code, you're probably interacting with an LLM every day. It's auto-completing your code, writing your doc strings, maybe writing your unit tests. Of course, ChatGPT is one of the most famous transformers in production. But it's also used in some very interesting domains, like in the sort of foundational sciences. Transformers are used to model the sort of structure of proteins. And this was one of the big breakthroughs that DeepMind made with AlphaFold. And of course, Google has now integrated transformers into their search to try and improve the sort of results that users get for sort of ambiguous queries. So you're probably on Twitter and you're thinking, oh man, there's all this like cool stuff happening. Can I have some state-of-the-art tools? And you think, okay, I'll go grab a textbook of machine learning, and it will probably give you some diagram like this. It will say like, you just get your data set, you get some pre-trained model, you train it, you deploy it, and then, you win. But as we saw from Tobias's talk, the reality is a fair bit messier. So you're going to need, first of all, some data. You're going to have to install Python. Oh, you need some libraries. And you're going to go, oh, okay, now I need to connect to the hub. Oh, I need some data sets. Oh, I need deep learning, so I need to get PyTorch. Oh, no, I need some GPUs, so I need to get some hardware. I have to get it from AWS. And you can see that this process is like getting more and more complicated. And this is more or less an accurate representation of being an ML engineer. So you're training the model and it's going well. You still need more GPUs because they all died. You're trying to log it, and then eventually you have to deploy it, serialize it with some Onyx, and then build an application. And if everything goes right, you've now got this giant, mess. You've broken prod, and you get the idea, right? This is more or less what it's like. Not glorious. So the key thing that we try to do at Hugging Face is figure out ways to improve your iteration speed. All of this stuff is lots of moving pieces, and the faster you can iterate through them, the faster you can get to deploying useful products. So the core thing in most of machine learning is indeed data. And so we have a library that we call the datasets library. You'll notice, actually, you saw this in Leandro's thing. He says, we call these projects like big code and big science. We're really super boring at naming things. So we have a library called datasets for datasets. It actually used to be called NLP at once upon a time. And people got so angry because when you write pip install NLP, then it breaks all your extra pipelines where you had any NLP variables. And so, yeah, we had to change it. But datasets, we've got 100,000 datasets that are contributed by the community, freely available. It's basically built for scale. You can process datasets up to 15 trillion tokens with no worries. It's multimodal, so you can process audio, video, images, and text. And one of the things that we try to focus on at Hugging Face is having kind of core integrations, not just with a single framework like PyTorch, but also with TensorFlow, Pandas, and so on and so forth. And the way this works is usually we try to build APIs that minimize the barrier for people entering the field. So if you're trying to sort of load a data set, it's typically just a single line. It pulls this IMDb data set from the Hugging Face hub. And then you can apply some processing on top of this using some clever tricks that make this go very fast, cache it, and also enable multi-processing. And so generally speaking, the data processing that you may have experienced when you worked with Pandas previously typically becomes a lot simpler when you're using this dataset library. Now, that's just the first part we saw in the video. The second part is, okay, now you need a model. And again, Hugging Face has many pre-trained models that have been contributed by both individuals and companies, like Meta, Mistral, and so on. And again, we try to keep things as simple as we can. So here you can see this is what it takes to basically load and process text of a pre-trained model, which is GPT-2, kind of a small one, which at the time was large. And we have over 100 of different architectures supported in the library and over 100,000 pre-trained models on the hub to choose from. And one of the things that we really enjoy about working with the community is that people will typically share their models, and then those models are used to build other models. And there's a kind of emerging trend at the moment of what's called model merging, where you actually combine different fine-tuned models to create these Frankensteins, but they tend to have high performance. And that's one of the kind of exciting things about having a community-driven platform. And when ChatGPT came out, everyone had been kind of fine-tuning transformers for a long time. They'd fine-tune them on very specific tasks like summarization or entity extraction. But what ChatGPT showed was that there's an additional step needed if you want to build a chatbot that is somehow aligned to a set of human preferences. And so there's a library that was actually built by Leandro called TRL, or Transformer Reinforcement Learning. And this now abstracts a lot of that complexity that goes into doing reinforcement learning with language models, and also provides a series of state-of-the-art algorithms that allow you to essentially build very capable chatbots using open source models. And one of the other interesting things that has happened in the last year or so has been the realization that you don't have to do a full training of all these model weights. So if you're working with large language models, you're typically dealing with billions or tens of billions of parameters. This can be very expensive and heavy to train, but there's been some very interesting developments about doing essentially sort of small updates of these weights in such a way that you only have to train a few megabytes of data, and that's the thing that you can actually then push to the hub and keep the rest of the base model frozen. And this is now, in my opinion, one of the biggest democratizations we've seen of AI, where you can now fine-tune large language models almost on your Mac, which is getting pretty cool. And as I mentioned before, this isn't just about using, PyTorch, that's what I do, but we also have integrations with JAX, TensorFlow, and Keras. And so by being kind of agnostic, we're able to kind of accommodate a broad slice of the whole ecosystem. So you've trained a model, you think, great, my job is done. And then, your boss says, well, you've got to actually make a demo. And this is a sort of accurate representation of the pain a back-end engineer feels when they have to build a demo. So it's like, messing around with a terabyte scale data set, that's a bit of a headache. Implementing a new architecture from scratch, dealing with CUDA, but building a nice demo, if you've never done front-end, that's pretty painful.
Yeah.
And one of the things that's been really cool to see is the emergence of frameworks that make this much, much easier for data scientists and ML engineers, especially people who are more familiar with Python. So I'm sure most of you have heard of Streamlit. This is a very popular framework for building web applications purely in Python. At Hugging Face, we have a framework called Gradio, which takes a similar approach, but is much more focused on just building machine learning applications. And we also have the ability for people to basically host on the Hugging Face Hub what we call spaces. These are essentially templates of various different applications that you can essentially have different types of UIs, different types of applications basically just running on the hardware that we have. So the idea, if you want to see an example, is like in Gradio, you essentially just have a simple file called app.py. You say, what the title of the application is, you have some description, and then you just point to a model on the hub that you want to load, and then this will basically launch and give you a very nice kind of clean UI that you can then show to your end users, and they can immediately start chatting with the model in this case. The other thing that's quite nice that we have on the Hugging Face Hub is hosted infrastructure. So if you want to run your application on GPUs, that's also an option. And just today, we shipped a feature where you can also basically run in dev mode on your space. So it's kind of like having VS Code on the Hugging Face Hub, so you can directly develop and build your applications that way. So the kind of thing that has emerged from all this development around transformers and pre-trained models is this kind of unifying theme of how do you bring all these different artifacts together in a single place. And that's essentially what is the Hugging Face Hub. And today, it's the sort of host of over 500,000 open source models. We have over 100,000 data sets. Every day, it's over 1 million downloads of these artifacts. And we typically have around 700,000 daily visitors. And the sort of goal that we're trying to achieve here is this idea of building like not just open AI tools, but also this collaborative nature of AI systems. And so one of the things that you may have heard in other talks is this kind of like distinction between sort of like the sort of closed AI companies, OpenAI, and also more open companies, where the idea is you try to build with the community progressively better and better tools. And so if you're trying to answer the question, what the hell is Hugging Face? Roughly speaking, it's like the GitHub of AI and ML. So I want to end with like a very kind of concrete example of what collaboration can look like. This is a project I worked on a couple of weeks ago. And the basic, so what I do at Hugging Face is I do a lot of research on fine-tuning language models and trying to find efficient ways to do them. And part of that involves looking at the literature and seeing which algorithms seem most promising for the community. And there was this paper that appeared on the archive from some master's students in Korea. And what they were showing was that the standard way that we would typically fine-tune models would, on the left-hand side, you would typically do some whole reinforcement learning complicated thing. Or you might try some simplified approaches such as DPO, which is a very popular algorithm for creating chatbots. And what they were showing was that there's actually an even simpler way where you can basically halve the amount of GPU memory you need, but get very similar or better results. And so this was something we discussed in the team. It was very exciting. This is around the middle of March. And then a couple of days later, Kashif, one of my teammates, he added this to the TRL library. And he had like a very nice API that says, you just define some config, you have a trainer, and you just train, and it now gives you this very kind of cool, efficient chatbot. And so this is like the first step of what happens in open source ML. There's usually a paper that gets converted into code that is then merged into some open source ecosystem. And then the next thing that typically happens is you need to find some data set that is going to work well with that algorithm. And completely unrelated to this work, there was a company called Agila who were doing lots of interesting research and work around how do you build high-quality data sets for AI assistants without having to go through the standard process of having human annotators. So they do a lot of research on like synthetic data generation and also synthetic labeling. And they happen to be working on building one of the very first like multi-turn data sets where you basically have two LLMs or multiple LLMs communicating with each other as a sort of like a human would with ChatGPT. And then you have GPT-4 kind of acting as the judge and annotating and saying, well, you know, in this case, this answer was good, this answer was bad. And so this data set has about 15,000 of these interactions between LLMs. So it's purely synthetic, no human oversight. And we thought to ourselves, well, this seems like a pretty good fit for this new algorithm because we want something that's both memory efficient but also cheap to run. And so this was a couple of days after the algorithm was in GitHub on TRL. And then Mistral did what they do. They dumped on Twitter a magnet link to some brand new model. And this is sort of the standard way they release things. The community basically has zero information about what this model is. It's just you download a bunch of files from BitTorrent. And to give you an idea of the speed of the community, some random anime character called V2 Ray in under 6 hours had downloaded this model, which was 141 billion parameters. So this is about 250 gigs of model weights, converted it into the transformers format, and then pushed it to the Hugging Face hub. So within half a day, we basically had this like completely unknown new model. No one knew if it was any good, but coming from Mistral, there was a good chance it was. And so I thought, well, maybe we could work with these researchers in Korea, with the company Agila, and bring everything together to see if we can train this model with this new algorithm. So we tried, and like no joke, 3 hours later, we had a new model. And this was a really cool thing because without knowing anything about this model, we suddenly saw that on many benchmarks that are used for evaluating the capabilities of chat models, the green line here is this new fine-tune, and it was state-of-the-art for about half a day. So the field moves so fast that we got to say we were state-of-the-art for a bit. But it was a really cool experience showing how you could basically bring all these different people across the globe together in a very short amount of time to build something that was quite exciting. And I was going to show you a live demo, but the demo gods are against me because I just tried to talk to the model and the API is down at the moment. But if you go to hf.co/chat, we essentially have a platform where you can chat to a whole variety of open source models. And these models have very different capabilities, they have very different personalities, and this is a very nice way of trying to understand and evaluate if a new open source model comes out, how good is it going to be for your use case. And I think maybe to conclude, we can probably say that it is indeed possible nowadays, if you're a software developer, to get access to state-of-the-art technologies. And without further ado, I'll take some questions.